fraction. On the top of the fraction, it starts with T1, and then open bracket, r to the power of n minus 1, close bracket. And the minus 1 this time is not part of the exponents. It's down in the main equation. So it's r to the n and then minus 1, not r to the n minus 1. Okay, r to the n minus 1. And on the bottom, we have r minus 1. Okay, so again, we'll start with a straight up example, just an easy one, and then we'll go into some word problems and some harder examples. Geometric series is your title. So find the sum of the first 9 terms for this series and state whether it's convergent or divergent. Let's do the second part first because it's the easiest. Converging or diverging, and how do we know? The silence. Converging is the offer. How do we know? Going down by 1/3, so the r value is a fraction between -1 and 1, or the numbers are approaching 0, so they're going towards 0 means it's convergent. So write down converging as the second part of the question. Okay, formula is T1, bracket r to the n, minus 1 bracket, divide by r minus 1. Do we have T1? Yep, what is it? Do we have r? Okay, take any term, divide by the previous term. It's going to be 1/3. And I'm bracketing it for a reason. Do we have n? So how many terms do we want the sum of? 9. Minus 1 is just minus 1. And on the bracket, on the bottom, it's 1/3 minus 1. Now, depending where and when you bought your calculator, you might have a brand new operating system, which is really pretty and nice. You might have the old operating system, which is harder. So when you hit the division, if you get a little fraction, like it actually shows you box divided by box, that's the new operating system, and I'll talk to you in a second. If you hit a division symbol and it just leaves it like that, you can't see that, that's the old operating system, and I'll talk to you guys first. Okay, so if you've got a TI-83, which is an older calculator, or you have the old operating system, you're going to follow me. We're going to type what we see except whenever you have what we call is a compound fraction. A compound fraction is when there's lots of stuff on the top and lots of stuff going on the bottom. You have to put brackets around the whole top and brackets around the whole bottom. So it's one of the exceptions that you don't quite type exactly what you see. You have to bracket the whole top, bracket the whole bottom. Okay, so I'm going to open a bracket, 27. Open the bracket for the bracket in the formula. Open the bracket for the 1/3, close the 1/3. How do I do an exponent of 9? What do we call it? Caret, awesome, so caret 9. The reason I need those brackets around the 1/3, if I didn't have them, the calculator would just be doing 3 to the 9. And I know it's a 1 on top, so it won't matter for this question, but it won't always be a 1 on top. So we need to have the whole fraction to the 1/9. Then I'm going to minus the 1 in the formula, and I'm going to close. Then I'm going to do the divided. I'm going to open, 1/3, minus 1, and close. Bam, write that down, round it off to 1 decimal place. If you have the new operating system, when you hit the division, okay, mine won't do it, but you should get like a little fraction. Sometimes if you type the top and then hit division, you actually get a little fraction. Do you know what I'm talking about, new operating system people? Okay, you don't need those extra brackets. The trick is if you have them, that's okay. So I tend to just put them in whether I'm using old or new, but you don't need them if you have the new operating system. So you can just type the top, hit division, it'll flip it to like a fraction, and then type the bottom. Okay, either way, make sure you're getting the same answer because we don't want this just to be a calculator issue that you can do the math but can't use your calculator. Okay, so round into decimal place, 40.5. Sometimes what happens when you're in exam panic, and we'll talk about exam panic all semester, is your brain starts to do really crazy things. And your brain will look at something like this and go, well, that's got to be wrong because the number's way too small. I'm adding a whole bunch of numbers, and if I'm adding a whole bunch of numbers, wouldn't I get a really big number? Well, what kind of sequence is it? Converging, and that's why the question asks us to start thinking about a converging sequence. So we have 3. The next term would be then a third, then a ninth, then 1/27th, then 1/81st, then 1 over 243. And for example, let's take 1 over 243. Big number or little number? That's a little tiny number. So when you have a converging sequence, really the sum is going to be close to the first couple of terms because the numbers are getting smaller and smaller and smaller, and you're really adding like 0.00000001 each time. Okay, so don't let your brain freak you out that adding necessarily means big number. It doesn't if it's a converging sequence. Okay, let's do number 2. Throwing a word problem all the way at you. Second example. Read to read. Sentence in a book. Don't overthink it. Okay, let's read to understand. What's important in the first sentence? 2. We don't actually even care what they are, who they are. We care it's the number 2. What do we care about after the number 2? 4. And then? Again, biologists care and geneticists care. Mathematicians, we don't care. We just do the why or the how. They do the why. We just show them what to do with the numbers. What do we care in the second sentence? How many? Okay, so that tells us we're looking for a value. 5, and this is where generations might help you, but really it's asking for, well, and now we get into, is this T5 or S5? And that's the biggest question with this. Is this implying all of the generations preceding you, or just the 5th generation preceding you? What's the implication here? What does it think it wants you to find? All of them, because it doesn't say just the 5th. It also has generations plural. So make a note that there's an implied all in here. And the word all means what in math? Add it up. Okay, if it wanted just the 5th, it would say just the 5th. Or it would say the 5th generation without the plural. So all we care about as mathematicians is we got 2, 4, 8, ... and we want to find S5. See, words just complicate stuff. That's why we hate words. Okay, do we have T1? What is it? Perfect. Do we have R? Yep, take any term, divide by the previous term. R has to be 2. Do we have N? 5. Minus 1 is just minus 1. And then on the bottom, we have 2 minus 1. This would be about the hardest we would ask you non-calculator. So you're looking at multiples of 2's, really easy numbers. So how do we do this non-calc? Well, we always go back to BEDMAS. What's the first thing we do with BEDMAS? Brackets. So inside the brackets, I've got to deal with this first. 2 to the 5. That's about the highest power we would expect without a calculator. So let's not grab our calculators and cheat. Let's do it together. 2 times 2 times 2 times 2 times 2, 32. And 32 minus 1 is? I'm just going to do the bottom right away because it's an easy calculation. 2 minus 1, 1. And I'm just going to put it imaginary because we know we don't need the 1 on the bottom. And then it's a straight up 2 times 31, 62. That would be about the most difficult we would ask non-calculator. Example number 3. Find the sum of the following. So we have -1, 4, -16, all the way up to 16,384. We did the exact same question with arithmetic, so the numbers were obviously smaller. Can we find the sum right away? No. What are we missing? So what do we not know?
We don't know what term 16,384 is.
Yeah, do we know how many terms are in the sequence? No. So this is a two-stepper. We got to find n first. Okay, we did this yesterday. How do we find n in a geometric series or sequence? So we can't use the sum formula because we know we don't have n, so we need to flip to the Tn formula. What's the Tn formula? It's in the notes. You can just flip back. It's in a box. Ooh, I'm really glad somebody said that because that's a really common mistake. This is for what kind of sequence? That's arithmetic. Are we dealing with arithmetic sequences? No. And that's why now that we've got two Tn's, we've got to put in our head geometric, geometric, geometric. So the Tn formula for geometric is? It's in a note box in the notes. We highlighted it. We wrote it. T1 times r to the power of n minus 1. Again, this time that minus 1 is up in the exponent, not down in the main equation. Okay, do we have a value of the last term? Okay, let's put it in, 16,834. Do we have a value of the first term? Minus 1. Do we have an r value? Okay, so take any term, divide by the previous term. R has to be negative 4. Do we have an n value? Oh, yeah, yeah.
I think you punched into the wrong number.
What did I put in by mistake?
16,834, I think it's 38.
Thank you. Good eyes. High five. Do we have n? Nope, it's what we're looking for. We did 2 of these yesterday. Okay, so what was the first thing we did in the example yesterday, or looking at the equation, what's the first thing we need to get rid of? The negative 1. So how do we get rid of a negative 1? Divide by negative 1. What can I do with these two negatives? Why? Yeah, so both negative, we can divide through by a negative just to get rid of them. So basically we cancel the negatives. Okay, what did we do yesterday when we were at this point? We used the calculator to figure out something. Yeah, so we use the calculator and we're looking for 4 to the what gives us? 16,384. So it's not going to be 2, it's not going to be 3, we got to go bigger than that. So someone give a guess. Okay, 4 to the 7. I love that because he doesn't even have his calculator. It's pure guess. I love it. Is that right? Did you know that? He did. Look at him. So we're going to put in 4 to the 7 in its spot. And then what did we get to do here? So once we found that common base, what did we get to do with them? We cancel. We cross them out because we know the two exponents have to be equal. N equals 8. Are we done? No, that was only the first half of the question. Welcome to pre-cal. Okay, now what do we want to do? The sum of the first 8 terms. Do we have T1? Do we have R? Do we have N? Ooh, be careful here. 8, because that minus 1 isn't part of the exponent. Remember, it's down in the main equation. And then on the bottom, we have minus 4, minus 1. Beauty of the graphing calculator is you don't worry about all this. You just type what you see. Remember, if you've got the old operating system, it's a bracket around the top, ooh, and a bracket around the bottom. If you've got the new system, just type away. Offer 52,428. That sounds confirmed? Okay, different offer? 7? Okay, that sounds confirmed, so let's just check that first one again. But how can it only be 13,000 if the last term was 16,000? And this is what your brain's going to do in exam panic. You're going to go, bah, that can't be right. And you're going to do the question all over again, and I'm telling you, you're going to get the exact same answer of 13,000. So why can the sum be 13,000 if the biggest number is 16,300 and something, something, something? So use a bit of little logic skills here. Yeah, what do you know about every second term? It's going to be negative. So if you're dealing with what's called an alternating series, the sum may not be that big. And again, your brain is going to tell you the sum needs to be huge. It doesn't need to be with an alternating series. She's already holding her head. She's like, this is too much. Can't deal with it. How are we feeling? Are you ready for a Jamungo word problem? Okay, this is why we read to read, because we don't want to freak ourselves out. We just want to read it like it's in a book. We're not going to panic. We're just getting the general idea of what's going on. 13,107. Okay, so just read to read. Don't overthink it. Don't panic. Just put the context into your head. Sorry? Okay, so a couple of things. Number one, did you have to interrupt me to ask me that right now? Where could you find that information without asking me? Okay, just tell me generally what's this about? Medicine, something's going on with a patient. Okay, first sentence, what's important? 200, and there's one other thing I would highlight. First day, because it's telling you that that's T1. I don't really care. It's a doctor, it's a hospital, it's medicine. I don't care. I care about the number. The second sentence. It's halved. Each successive day for some brains might be important. 7 days. Okay, the last sentence. What does mg stand for? Milligrams. So that's, if you think of a gram, the weight of a gram is about a paper clip. So put out your hand, and I want you to imagine I just put a paper clip in it. Okay? A milligram is 1/1000th of a paper clip. 1/1000th of a paper clip. So would you like your doctor to be dead on with how many milligrams, or would you like him just to round it off? Yes. So what happens if he gives you a milligram too much? You could die. And that's 1/1000th of a paper clip. That's why we like doctors to take pre-calc. That's why right there. Yeah, nurses too, we like them to know math. I don't want to die. How many milligrams? Actually, that's enough for the last one. Okay, so let's translate this into math. What I like to do is just write out the series, because once I see this series, I can figure out T1, I can figure out R. If your brain likes to list off to the side like we did before, then do that. We know the first day is 200 milligrams. How much is the next day? 100th. Why is it 100th? Because it's half. The next day? ... And what are we looking for? So is it T7 or is it S7? And this is always the hardest part. Are we looking for the amount of the drug on the 7th day or the amount of drug over the whole 7 days? Natasha?
The amount of the whole 7 days.
How do we know that? What tells us that in the question?
How many milligrams of medication does the patient receive?
Bam, it finishes. Does it say on the 7th day? No, so this is implied overall. Okay, so this is going to be an S7. T1. Whoa, what's the potty mouth going over there? R? Again, take any term, divide by the previous term. N? We do know N, look over here. 7. Again, -1, remember, in this formula is down in the main equation. And on the bottom, we have a half minus 1. Ooh, I was like that. Sorry, 396. Point. Non-rounded. Confirm. Units. What? Oh my God, what? 3. Even?
Well, no, 0.9948.
So if we were to round that, it would be 400? Okay, so let's debate between these two, so fight it out. Okay, it's a good way to do to check. Okay. Okay, confirm the first one, so let's double check. Sorry? I didn't hear what you said. Okay. Okay. Okay, so I hear we have 3 confirmed for the first one, 2 confirmed for the second. The first one, so now we're 3 and 3. There's a lot more of you in the room to confirm.
I got 396.7.
So now we're 4 and 3. We're trying to confirm which answer it is, so we're just double checking. Yeah.
Unless you're putting it in wrong, so I'm not getting it.
What are you getting?
Like I've varied from like negative 397.
Which we know can't be right because it's not a negative, okay? Do you have old operating system or new operating system? Okay, so I want you, who else has the old operating system where you have to bracket? Okay, so I want you guys to just come together right now and compare what you have on your screen. Who has the new operating system? Okay, I want you guys on this side of the room, I want you all to compare your screen to each other. So old operating system, new operating system, compare what you have on your screen. Example number 5, read to reads.